I'm Anil Kumar. We are discussing a test paper on vectors. Here is another question. We'll see how to solve such questions. The question here is, consider the points A 1 minus 2 minus 1, B 7 minus 4 3, and C 1 minus 2 3. The line L1 passes through C and is parallel to AB. Line L2 R equals to minus 1 2 15 plus t times 3p minus 6 is perpendicular to L1. Find the coordinates of point of intersection of these two lines, right? So we need to find point of intersection in this case, right? You can always pause the video, answer the question, and then look into my suggestions. So we are given equation one of the lines. Let me write down that equation first, which is L2 R equals to minus 1 to 15 plus t times 3p minus 6. You will see p is unknown here, right? This is unknown, right? Okay. And we also know that these two lines L1 and L2 are perpendicular. So we know L1 is perpendicular to L2. Now let's find out the equation of line L1. It says that the line L1 passes through C and is parallel to AB. So we need to find the direction for the line L1, which is parallel to AB. So let's find what direction AB is, right? So we could write AB as equal to, so from A and B the values given to us, we can say AB is 7 minus 1, okay, minus 4 minus 4 minus 2, 3 minus 1, 3 minus 1, correct? Okay, which is equal to 7 minus 1 is 6, and that gives us minus 2, and 3 plus 1 is 4. So that becomes the direction for the line, right? And says it passes through C, which is 1 minus 2, 3. So the position vector will be 1 minus 2, 3. So line L1 we can now write as R equals to position vector C, 1 minus 2, 3, plus let's say S times the direction 6 minus 2, 4. Actually, we could actually simplify this direction also, dividing by 2. We could do that. Anyway, let's continue with this. Right. So now we know that lines L1 and L2 are perpendicular. Since L1 and L2 are perpendicular, their dot product of their direction should be 0, right? So we'll use that idea. L1 and L2 is perpendicular. That really means that M1 dot M2 is equal to 0, right? So now we'll use that part. M1 for us is 3p minus 6. That is M2. Doesn't matter. We could rewrite in any way. Let's rewrite this first. 3p minus 6. It's a scalar quantity. So, and the order does not really matter here, right? 6 minus 2, 4, correct? So let's multiply. 6 times 3 is 18, dot product I should say, minus 2p and minus 24. That should be equal to 0. That's the whole idea. It helps us to find the value of p, right? So solving this, we could write 2p, let me write down here, 2p equals to, we'll take these terms on the other side, 24 minus 18, which is, so it is 6, right? Or p is equals to, as minus 2p, because we took those terms here. So we have p as equals to 6 divided by minus 2, which is minus 3. Now since p is minus 3 for us, we can actually write down the equation of L2, right? So that gives us the equation for L2 as R equals to minus 1 2, 15 plus t, 3 minus 3 minus 6, correct? So that becomes the equation of the line L2. Now we are in a position to find the coordinates of point of intersection of these two lines, right? So to find point of intersection of these two lines, we can match their parametric equations and solve the equations, correct? So for the first line, now L2, let me write from here. The point here is x is equals to minus 1 plus 3t, y is equals to 2 minus 3t, and z is equals to 15 minus 6t, right? So that is for L2. For L1, we have x equals to, so that is L1, 1 plus 6x, 1 plus 6s, y is equal to minus 2 minus 2s, and z is equals to 3 plus 4s. We have two parameters t and s which we need to figure out. So we'll actually solve the set of equations, these two equations. We'll solve these two equations. Then substitute the value in the third equation to find the point of intersection, right? So that's the whole idea. So let me use this side of the page to solve this set of equations. So the first equation which we are going to pick up is their x values. So at the point of intersection, their x values, y values, and z values should be same. So we have minus 1 plus 3t equals to 1 plus 6s. Now, bringing them together, we could write, I'm bringing 6x to the left side, so it becomes 3t minus 6s equals to, taking this 1 to this side, 2, right? So that becomes one of our equations. Okay. So let me name this equation 1, 2, and 3, and I'll call this as my equation number 4. Now let's check with y values. We have 2 minus 3t equals to minus 2 minus 2s. Bringing s to this side, what we get here is minus 3t plus 2s equals to 2 to the other side minus 4, right? So let me call this as my equation number 5. You can see very clearly that if we add these equations, then 3t and minus 3t will cancel out. So to solve for one of these parameters, we'll do equation 4 plus equation 5. And that will give us the value of s. So when I add, I get minus 6 plus 2 as minus 4s. So we get minus 4s equals to 2 minus 4, which is minus 2. So the value of s will be minus 2 divided by minus 4, which is half. So we get the value of s as half. Now to find t, we can use one of these equations, substitute the value of s and find t, right? So let us use, you can use any equation. So let's use equation 5. So in equation 5, we'll substitute the value of s as half and then find the value, right? So let's do it on the right side. So we'll still have a lot of space here, okay? So what I'm saying here is that we have s equals to half, and we are going to substitute this in equation 5, which is minus 3t plus 2 times s is half, equals to minus 4, right? So that gives us minus 3t, and this is 1, right? Plus 1 equals to minus 4. Taking this on the other side, so we get minus 3t equals to minus 4 minus 1, which is minus 5, or t is equals to minus 5 over minus 3, and that is 5 over 3. So we get the values for both s and t, right? So what we finally get here is that s is equals to half and t is equals to 5 over 3. We can substitute these values in our equation and find the x, y, and z values, correct? Okay, so let's do that. So t as half and s as 5 over 3, right? So if I substitute t as half, s as half, so we'll do this line 1 first. So x is equals to 1 plus 6x, 6 times half, and that gives us 1 plus 3, x value is 4. For y, when we substitute half, we get minus 2 times half, which is minus 2 minus 1, which is minus 3, and z value is 3 plus 4 times half, that is 3 plus 2, and that is 5. Now you could actually check the z value from here also. Is it same? Right. So let's substitute t as 5 over 3 here. So we also get z equals to 15 minus, let me push this page a bit, 6 times 5 over 3, right? That means 15 minus, that is 2, 10, which is again 5. So they match, right? So that means we do have a point of intersection, and the answer therefore is the x, y, and z values are 4, minus 3, and 5. Correct? So that is the answer for this particular question. I hope all the steps are absolutely clear. This question is very important. So first, we found the equation of the line from two given points that gave us the direction. Third point defined the position. We found a parameter also, knowing that the two lines are perpendicular, and then we solved the equations to find point of intersection. I'm Anil Kumar, and I hope you're enjoying this review and understanding this topic, vectors, especially when applied to equation of lines. You can always post your comments and suggestions. Feel free to share and subscribe my videos. Thank you and all the best.